Information retrieval. My name is Yan. I'm the chair of this session. I come from Peking University. So let's go to the first paper, with the title of Cluster-Based Focus Retrieval, which is presented by Eilon Sheetrit. Okay, let's welcome the speaker.
Hi everyone, so my name is Eilon Sheetrit. I'm a PhD student at the Technion. Today I'm going to present you my work that is titled Cluster-Based Focused Retrieval, which is co-authored with my advisor, Professor Oren Korland. So the goal of the focused retrieval task is ranking passages of documents by the relevance to the information need expressed by query. We define a passage as any sequence of text in a document, which is often much shorter than the entire document length. Our research goal is to devise retrieval methods for focused retrieval that utilize inter-passage similarities. Now, in order to understand our research goal, we need to start with the vocabulary mismatch problem between short queries and short relevant passages, which is even more severe than the case of documents. Therefore, surface-level similarity is not a sufficient signal of relevance. Now, several ways were proposed before to address this problem. For example, by smoothing the passage if it's containing document, or if it's neighboring passages, using query expansion or semantic similarities. Here, we decided to address this problem using inter-passage similarities. As it was shown for document retrieval, the document retrieval methods that utilize inter-document similarities yield highly effective results. In addition, it was recently shown using a set of cluster hypothesis tests that inter-passage similarities bear information about relevance to the query. So here is an overview of our proposed class PSG method. Given a query, we retrieve an initial list of documents. Then, we rank the passages of the documents using some effective passage retrieval method. We take the top results and cluster them. We follow previous work and use nearest neighbor clustering with language model-based similarity measure. Once we have a set of clusters, we rank the clusters using a learning to rank approach. We basically represent a pair of a cluster and a query using the following features. Two query-independent features, which are the geometric means of the reciprocal rank position of the cluster's passages in LG and of their documents in LD, and additional four cluster priors, which are, for example, the geometric means of the entropy of the term distributions and the appearance of stopwords in the cluster's passages. Now, once we have a ranking over clusters, we transform it to a ranking over passages by just replacing each cluster with its passages, while omitting repeats as the clusters can overlap. We end up with a ranking of passages which should presumably be better than the initial ranking LG. So our approach is inspired by the class MRS method, which is a supervised cluster ranking approach proposed for document retrieval. We adapt some of its features in addition to providing new features. In addition, feature-based passage ranking approaches were proposed before, but they do not utilize inter-passage similarities. And of course, there is a growing body of work of using neural passage retrieval. An interesting future direction would be to integrate our approach with neural architectures. So we applied our class PSG method on several initial retrieved lists created by different retrieval methods. And we use the INEX and Acquaint datasets in our experiments, for which, for INEX, we used focused relevant judgments, which are the markups of pieces of relevant text in relevant documents. And for Acquaint, the marked sentences were judged as relevant or non-relevant as a whole to the query. Now, the motivation of using these two datasets is that for INEX, the average fraction of relevant text in relevant documents is 0.4. And for Acquaint, the average number of relevant sentences in a relevant document is 0.37. Therefore, the majority of the text in a relevant document is non-relevant, and focused retrieval is required. So here are the results over the INEX dataset. The blue bars present the effectiveness as measured using MAIP of the initial passage retrieval methods. We use, for example, a language model-based approach, which generally interpolates the passage query with the document query similarity score, and a feature-based approach. MIP is the mean average interpolated precision over 101 start and recall points, And interpolated precision is just defines precision at any recall level. Now the yellow bars present the performance we get by applying our proposed approach on each of the initial ranking lists. As you can see, there are quite major differences. And we found using feature analysis that query-independent priors that used by our method are highly effective, and that our approach is highly effective in re-ranking different initially retrieved lists. Now, motivated by our approach, we further demonstrate the potential of using inter-passage similarities for the task of focused retrieval. So we perform the following experiment. Let's say that I were to take the top 100 ranked passages in the initial list and to cluster them into clusters of size 10. Now let's say that Oracle would have told me what is the fraction of relevant text within each of the created cluster, and I were to pick up the cluster with the highest fraction. The green bar presents the result that I would have attained by doing that. The blue bar presents the average fraction of relevant text in the top 10 ranked passages, and the yellow bar presents the fraction in the cluster that is most highly ranked by our proposed approach. As you can see, there is a huge room for improvement, and the meaning is that by identifying the cluster with the highest fraction of relevant text, we can potentially improve the effectiveness of focused retrieval. So to summarize, we propose the novel passage retrieval approach that is based on ranking clusters of similar passages using a learning to rank approach. We found that query-independent priors are highly effective, and according to empirical evaluation, demonstrated the effectiveness of our approach and the further potential of utilizing inter-passage similarities for the task of focused retrieval. Thank you very much.
Okay.